Finding error intervals with Tutor. Here are the beginner questions, some of the easiest questions that you're likely to find on this topic. An error interval shows the range within which a rounded or measured value lies. It indicates the possible minimum and maximum values that a number could have been before it was rounded. For the first question, a equals 60 and has been rounded to the nearest 10. Identifying where the rounding line would go when rounding to the nearest 10 will be helpful. This is my units column and this is my tens column. So rounding to the nearest 10 would place my rounding line here. The upper bound is the largest value it could have been before being rounded. This can be found quite quickly by placing a 5 in the column immediately to the right of the rounding line. By definition, it has to be strictly less than the upper bound, so wouldn't actually include 65, since this would round the number up to 70 when rounding to the nearest 10. The lower bound is the smallest value the original number could have been before being rounded. A similar method can be used to find this quickly. We can put a 5 after the rounding line, but we need to remember to take away 1 from the number before the rounding line. So in this case, the lower bound would be 55. When writing this as an error interval, we can place our lower bound on the left and our upper bound on the right. And we're saying that a is greater than or equal to 55, but has to be less than 65. We do not put less than or equal to, as it has to be strictly less than the upper bound. The inequality symbols that we've used within the interval will always be the same, so it's worth remembering. The only thing that might change is the letter that we use in the middle, and that's normally given to you in the question. For the second question, x equals 15,000 and has been rounded to the nearest 1,000. Write as an error interval in terms of x. Notice the slight difference in language compared to the first question. The first question said find the interval within which the actual value of m lies, and the second question quite simply states write as an error interval in terms of x. Even though these are written slightly differently, they're requiring us to do the same thing to find the error interval. This would be my units, tens, hundreds, thousands column, meaning my rounding line needs to go after the 5. Using the method previously, I can find the upper bound by putting a 5 after the rounding line and keeping everything else the same. And for the lower bound, I can put a 5 after the rounding line, but I need to remember to take away 1 from the number before it. So my lower bound is 14,500 and my upper bound is 15,500. X is greater than or equal to 14,500, but is less than 15,500. On to the intermediate questions with a slight increase in difficulty. N is equal to 0.3 and has been rounded to 1 decimal place. Write down as an inequality to show the range of possible actual values. Again, written slightly differently, but still asking us for the error interval. 0.3 rounded to 1 decimal place would put my rounding line after the first decimal place, which is the 3. Using my method, I can keep everything the same and place a 5 after the rounding line. And for my lower bound, I can do the same, but remember to take away 1 from the number before the rounding line, meaning n is greater than or equal to 0.25, but less than 0.35. For the second question, x is equal to 540 and has been rounded to 2 significant figures. The first significant figure would be the 5, and the second significant figure would be the 4, meaning my rounding line goes after the 4. The upper bound would be 545, and the lower bound would be 535. So my error interval would be x is greater than or equal to 535, but less than 545. On to the advanced question, one of the trickiest questions that you're likely to find on this topic. X equals 62.1, truncated to 1 decimal place. Find the error interval for x. Truncation is a method of approximating a number by shortening it to a specified number of decimal places or significant figures without rounding. It involves simply cutting off or ignoring the digits beyond the required level of precision. For example, if I had the number 62.19 and I was truncating to 1 decimal place, you would put your truncation line after the first decimal place, which is the 1, and rather than looking at this number, deciding whether it's 5 or more, and whether you need to add 1 to the number before the line, we don't need to worry about doing any of that. we simply just get rid of everything after the line, regardless of whether it's 5 or more or not. So 62.19 would truncate to 62.1. When it comes to finding the upper and lower bounds, the number you see has to represent the lower bound. Since every number after the blue line has been cut off, the very least we could have had would have to be 62.1. And for the upper bound, we could have any number of digits after the 0.1, with the largest just being recurring or consecutive 9s after the first decimal place. Since the upper bound represents a value that it has to be strictly less than, we can replace the 0.19 recurring with 62.2. So a shortcut would be to keep the lower bound the same as the truncated number, and the upper bound will be the same, but you add 1 to the number before the truncated line, meaning x is greater than or equal to 62.1, but is less than 62.2. Here's a question I completed earlier. It appears as though I've made some mistakes. Pause the video and see if you can tell me what they are, or write some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.